the emphasis of the session today, as the title suggests, is to basically run your first agent, but then also learn about how you can make adjustments to it in order to, push it in a particular direction, get it doing what you want it to do. Before doing that, I just wanted, before kind of diving in, and Jose will be leading the majority of that. I also just want to say a small disclaimer before we start, that basically this academy is for anyone interested or already part of Olas. It's organized by Valory, which is the dev company and one of the core contributors to the Olas ecosystem. And all of this content is our view and not financial investment advice. So I think with that, we can get started with the session today. I will hand over to Jose, who has prepared a lot of exciting things to show you around running and tweaking your first agent. So over to you, Jose.
So as Oak mentioned, the goal of this session is to show you how you can run your first agent, and also how to start tuning the agent. So we are going to somehow get introduced in setting up parameters for the agent, but we will devote other sessions to explore the code, let's say the internals of the agent itself. So this session essentially is just to present how everything works, how the agent is, the service is minted in the protocol, and so on. So I will give like slightly more detail than what we usually do on the sessions on the community sessions. Well, who am I? So I work for Valory. I'm a cryptography engineer. And my background, so essentially, has been always related to security and cryptography, both from a theoretical and practical side. So I have worked both on the industry and on the academia on these topics. So I think we have another slide for Oak. I think everybody here knows Oak, but just in case, if you want to make any remark, Oak.
I can go through it, yeah. So I'm co-founder and CPO of Valory, or also a founding member of the Olas DAO, early contributor to the projects that you see there, Ceramic, Thorchain, and Balancer. And yeah, I mean, I think everybody was here for the first set of calls, so I won't go through the block. But for the recording, our mission is to enable groups to co-own AI systems, beginning with decentralized autonomous agents. Yeah, so with that, please continue, Jose.
Okay, thank you. So, as I said, what we will cover today, we will review how this predictions agents use case works. We will go through the trader quick start. I will try also to guide you through what is going on behind the scenes on this trader quick start. I will show you also, as I commented, like a few methods on how you can modify the strategy of your trader, or how you can tune the parameters of the trader. And finally, we will devote some time for questions and next steps. So this is an overview of what we are going to discuss. So what is the, let's say, the system that we are going to run? So it's essentially a trading agent or a trading service that its goal is to place bets on prediction markets through the Omen platform. So let me show you. So this is the Omen platform. You can explore. You have here like markets for prediction markets for anything. So I don't know. This one, like, it's a question. So here you can bet for one outcome or the other, and when the market resolves, if you have if you have bet for the correct answer, then you get the rewards. So this is so essentially the infrastructure that we are going to run is an agent that executes bets on this market. So we have a mechanism for creating this market, so we can consider it as a black box for now. So we just need to know that markets are going to be created in the context of this setting. And we are going to have 10 prediction markets that close every day. And each market will be funded with 10 WX days. So this process, for now, we are going to forget about how this is done. So we just take that for granted. So how does this trading agent works on the, let's say, on a high-level view? So it essentially monitors this platform for suitable markets. Whenever it chooses one market to bet, this agent has to somehow estimate what is the probability of this market being the answer yes or being the answer no. So how does the agent do that? So essentially, the agent contacts an on-chain service, which is what we call a AMEC. And the AMEC is an decentralized service, which is designed to outsource AI tasks for a given DAI fee. So essentially, the market picks, the agent picks a market from this platform. It parses the question. It sends a prediction request to this MEC, and the MEC processes this prediction request with a set of tools and outputs how the agent should place the bet and the confidence on that prediction. And this is the output that is sent on chain, and the trading agent reads this output on chain. So this is essentially how this setting works with these different components we have here, like the trading agent, the MEC, the platform, and the market creation process. So what we are doing here is we are going to deploy an agent. Let's say we are going to deploy a service on our local machine. So a service, it's a collection of agents that execute together like a business logic in a decentralized in a decentralized and trust minimized way. So in the general case, a service is composed of multiple agents. In the case that we are going to execute this trading agent, we are just going to consider a service with a single agent. But of course, this can be generalized with multiple agents. So the service, which is this collection of agents that work together towards a functionality, in this case, placing bets on this Omen platform, is represented on chain as an NFT. So we are going to, let's say, mint this NFT that represents the service on chain. And this is going to belong to what we call like the service owner. So the service owner will manage the life cycle of this service on chain. It will, let's say, deploy the service on chain. So at that point, the different agents that compose the service can be run and can be and can operate together. So also, there's another component in this service, which is the safe. So the safe, it's the component that represents the service transactions on chain. So whenever a service needs to execute a transaction, agents need to reach consensus, and this consensus is let's say, materialized through this safe, which is the component that then places the transaction on chain. So, for example, in this case, to place a bet on one of those prediction markets. So, as I mentioned on the previous slide, so we have several entities involved here. The service owner, which is the entity that manages the life cycle of the service. The operator, which is the entity that has the infrastructure to operate one of the agents that compose the service. In this case that we are dealing with, just for simplicity, we are going to consider that the service owner is the same as the agent operator. But of course, in the general case, this can be separate entities. So the next, we have the agent, which is essentially the code that executes the business logic on each of the operators. And finally, the service safe, which, as I said, represents the service transactions on chain. So, okay, so let's start running this agent. So we are going to use the Trader Quick Start repository. So in case, well, I mean, I don't know where we have the links, but of course we can place them on the Discord, or we can share this on the chat. So we are going to use the Trader Quick Start repository, which essentially it's a repository to help you execute the operations with the trader agent. So what we need to, the requisites that we need to satisfy, we need to have some XDAI on the Gnosis chain. We need to clone this repository and execute the main script. So let me switch to the command line while I'm going explaining things. So I will just so okay, I have just cloned this Trader Quick Start repository. Can you read the my screen, by the way?
Yes.
Okay.
Yeah, all good.
Okay, so I'm going to execute this service, and I'm going to explain what's going. So first of all, we need an RPC node, so an RPC address. If we go to the Trader Quick Start, here we have some recommendations on how to get this RPC. So let me check. Yes, we recommend quick node. Okay, so now the script is essentially downloading the repository, the trader repository, which is the repository that contains the source code to execute the agent, and it's doing some other tasks. So let's review what tasks it's doing this script. So, well, the first it's going to do is going to create key material for the service owner, the agent, and the agent operator. So as I said, in this case, the service owner is the same as the agent operator. So it's going to create essentially two key pairs, one for the service owner and another for the agent. Next, it's going to ask fans for the keys. So it will prompt you what to transfer some XDAI to those keys, and downloads the trader source code, mints your service on the Olas protocol, and finally runs the service deployment locally as a Docker Compose deployment. So let's review what's doing this script. So first of all, it's going to ask you if you want to use a password to encrypt your private keys. So in this case, I'm not going to use a password. So the second thing, it's going to ask you if you want to use staking in this service. So currently we are running staking programs. What I would recommend if you are interested in staking, so I believe we have a session, community session tomorrow on Discord, where we devote time to staking. So for this example, I'm not going to use staking. So now, as I said, it's creating this key material. So you can see here, it has created two addresses. And the first thing that it's going to ask some funds for addresses to execute on-chain transaction. So give me 1 second while I transfer. While I make this transfer.
Who controls the keys for these addresses?
The keys are locally stored, are randomly generated, and are stored on your computer. I will show you later where you can find those keys.
Cool.
So now the script is executing the on-chain operation. So essentially, it's registering, it's minting this service in the on-chain protocol. So how can we see what it is doing? So we can, for example, go to this to the registry that we have, to the Olas registry of services. Make sure that you are on the Gnosis chain here. So if we go to the latest page, we are going to see, like, let's say, the latest service. So this is 221, 221. So let me see. I don't see here. Maybe I can do this. Okay, so it seems it's not updated at this point. But this is just, okay, now it's updated. So what has the script done here? So if you see the logs of the service, so it has minted the service on the Gnosis chain. It has activated the service. It has registered the agent, and it has deployed the service. So if we go to the Olas registry web page with the service number, in this case it's 221. You can see here, this is the service that I have just created and minted. So you can see that the script has registered the service. Well, this pre-registration is the minting. When you mint the service, you automatically enter in the pre-registration phase. The next step is active registration. So in this step, I can register my local agent on the protocol. And finally, when all the agents have been registered, so the service owner deploys the service. So a deployed service means that at this point, the service operators can run the agents. So this is, let's say, the default working state of a service deployed. So this has been done behind the scenes by this script. So now what's doing this script? It's asking for the agent instance funds. So this is also to pay the fees on the on the on-chain fees. So let me just make this transfer. Okay, and now the script should continue.
Did you stop sharing, or is it just me?
Say again, sorry?
I don't see a screen share anymore.
Yep, it's gone down for me as well.
Okay. Now can you see?
Yep, thank you.
Okay. So, okay, I didn't send the transaction. Sorry. Let me. Seems that the network is a bit busy today, so it's.
So many agents running.
Okay, hopefully now it goes through the transaction. Let's see. Okay, here we go. Okay, and finally, as I said, it's going to ask like a little bit more of funds for the safe. So why is that? So the reason for this is that this amount that it's asking here, it's the amount that is going to be invested on the prediction markets. So this is the amount that is going to be placed for bets on those prediction markets. So that's why here we can put as much funds as we want to devote to investment. So let me again send. this, and hopefully this is the last transaction, the last that I need to send funds. Okay, again, MetaMask is being a bit slow. Sorry for that. Okay, so okay, I think I also cancel. I don't know why this MetaMask plugin is giving me so much problems today. Okay, here we go. Finally, I could transfer this amount to the service. So essentially now what the script is doing is building this Docker Compose deployment and building the Docker images. And when it finishes, it will execute these images locally. Okay, meanwhile this is finishing, let me share with you some question that already appeared. Okay. So there was already a question about where are the keys stored, who control those keys. So if you are on the Trader Quick Start, when you execute the script, it creates this Trader runner folder where you can find, let's say, all the private key information that it has created locally. So this is all created locally. So you have control on those keys. So if you lose those keys, so you lose obviously any funds you have associated to them. Okay, so now that the service is running, so let's examine what the service is doing. So again, in the Trader Quick Start repository, we have a number of commands. Well, first of all, this runs as a Docker Compose or Docker images. So if you, for example, so the first thing you can do is just follow the logs of the trader. It's a Docker image, and you can see so how the image, like it's producing the doing, and so on. So the second command that I wanted to share with you, if you go to the section Observe Your Agents on the Trader Quick Start, you can, for example, inspect the state transitions using this command. So let me just copy the command and show you what this is doing. So this essentially it's displaying the different phases that the service is going through. So this is, let's say, a complex service. It has different phases. So, for example, let me select one. In this one, for example, update bets round. Sorry. Yeah. Sorry, in sampling round. So essentially what it is doing, it's contacting the Omen platform and sampling what are the potential bets to invest. So in this decision request round, what it is doing, essentially, it's sending a request to the MEC, as we have discussed here in this slide. Is sending a request to the MEC for them to get, let's say, a prediction on the market that it has chosen to bet. And depending on what the MEC returns, the trading agent will decide if it's going to place a bet on this market or not. So we have other command here. If we want, for example, to examine what trades have this agent posted, so we have this command here where we need the safe address. So let me copy the safe address. I don't know where I have it. 1 second. The MEC is an on-chain service, so it's another service like this trader, which operates on-chain. So what is happening here? The trading agent, it's when the trading agent wants to request, let's say, some prediction to the IMEC, what the trading agent is doing, it's placing this request on-chain. The IMEC monitors these on-chain requests, these events on-chain, and it produces the output. So the trading agent places the request on-chain and reads the response on-chain as well. So this is a service that we have running. So we have an IMEC hub. I can show you also the page where you can see. Okay, let me see if it's loading. Okay, here we have it. So in this page, in this app, what we have is what are the MEC requests being sent. So here we have, let's say, the hash. Let me see if I can examine this. So for example, no, sorry, this is not the request, sorry. Here it is. So those are the requests. So this is the requested data. So for example, let's examine one here that has a response already. So here we have, like, I don't know if you can read, maybe it's.
I can see it.
Yeah, I can see it fine.
So you see, it executes one prediction request for this concrete market. Will NVIDIA scan down version of whatever, yes or no? And in the same way, so here we have in this web page, you can also examine the responses. So this is the response that the IMEC placed on chain and was read by the agent. So possibly if we examine one, sorry, this one has an invalid. So let me check another one. Yeah, here we have the result. It gives the probability of yes is 0.85, the probability of no is 0.15, and the confidence in this prediction is 0.9. So with this information, the trading agent is going to decide if it's going to invest or not invest on a given market. It's a bit out of the scope of the presentation, but I can give you some details on this. So the idea is that the MEC is designed so that it has a number of tools, and it can be expanded through different tools. So, for example, we have a collection of tools for making predictions, So some of them are let's simple tools, like let's say that they make a call on an LLM or something. And some other tools are, let's say, a little bit more complex. So for example, like first they collect information on the internet, and then they group this information, call an LLM, etc. So this is like expandable. So so that's the idea. So that we have, let's say, a collection of tools, but we can expand this collection. So actually, in the hackathon that we ran like recently, so one of the prizes was about designing a MEC tool to make better predictions. But so as far as I know, the tools that we are using like external LLMs. So we are not implementing the model internally. As I said, so let me see if this trader agent has placed a bet. So okay, so it still hasn't placed a bet, so possibly it hasn't found a market with enough confidence to place a bet. So just to show you how this output look like, let me show you the output with an agent that has placed some bets. I think we are running a bit out of time already. So this is the output of the command for an agent that has placed some bets. So you can, let's say, when you have your agent and it has run for some time, so you will see something like this. So you will see if you execute this tool, which again it's described on the Trader Quick Start repository. So you will see, so for example, for this market here, it has placed a bet of 0.03 XDAI. Okay, and you can see here all the bets that have placed, and here you can see a summary of all the bets, like which are open markets yet that are open for placing bets, which are closed, the total, and so on. So, and also you have another command here, which I think I don't have time to show you in this presentation. But we have some other command that gives you like an overview of the status of the agent at this point. So I invite you to take a look at this repository and play with these commands that you have here in Observe Your Agents section. So the last thing I wanted to show you is how to start tuning up your agent. So if we go here to this to the Trader Quick Start repository. So we can see here that let me maximize this. It has downloaded this Trader repository. The script downloaded this Trader repository, which is actually the code that is executing the Trader service. So services are configured through YAML. So, for example, if I open this service, it's here. So this is the configuration for the Trader service. So you can see here, like there's a lot of parameters. So you don't need to read this file entirely, of course. So, but the idea is that we have some parameters here that can be tuned up. And how can you modify these parameters? So essentially, if you want to make a change in one of those parameters, so let me find, for example, this parameter, the dust threshold here. So what you have to do is you have to take this value and define an environment variable with the value that you want to change this. And this will overwrite the value that the service has by default. In this case, this is the default value. And if you export this environment variable with another value, when you run the service, it will overwrite this value here. So in this case, dust threshold is the threshold for which the agent is not going to claim wins, let's say bets that have won, because let's say it assumes that if it's less than this value, the price of the transaction is going to be more expensive than what it's going to get from redeeming this market. So you can tune up, for example, this value. So this is just a small example. You can also take a look at these values, some of these values, and if you have any questions about what they mean, so you can ask also on the Discord support channel. So the way this is done through the Trader Quick Start. So here I have this run service, which is the script that I just ran. So at some point here, we have these environment variables. So let me see. Here, so if you examine, for example, these variables here, this will match some of the variables that you have on the service configuration file. So, for example, in order to change that variable, so you need to do export threshold equal the value you want to put here. And then you just need to save this file and execute again, and it will take this value. And I think with this, so I'm a bit sorry because I'm a bit over time, but with this, I have covered everything I wanted to cover today.
In that case, thank you very much to Jose. It was there's a lot to get through there, and yeah, it was very, very well handled. Thank you all for coming.